first DNA is integration of WikiTalk into VirCA. VirCA is the Virtual Collaboration Arena system, and the professor was Kristiina Jokinen from Helsinki, and you see the period on the slide. Contact, or the project leader from our side, was Peter Galambos. The basic idea was to create an intelligent engine or answering machine which is able to answer various kind of questions from the user. The main idea is, as the title says, that WikiTalk, that this system is capable of searching the answer on the Wikipedia. So whenever you're asking a question, the engine is going to the Wikipedia and try to find answer. But the intelligence was not on the humanoid, I mean on this small engine, it was rather on the human, on the user, because let me say that the user should navigate in the Wikipedia after getting the answer, or let me say that the key answers or the keywords around the question. So it's a semi-intelligent in this way. So you are asking a question, the engine is going to the Wikipedia and find the closest topics, and then you are able to navigate within the Wikipedia. The navigation is based on some keywords, or the system is finding the keywords, how to go further or how to stop. So it's not a fully intelligence. So you need a kind of dialogue to navigate through the knowledge you are searching for. Okay, so why Wikipedia? There was a huge discussion because many engines like this is running on the internet and trying to find answer through the whole internet system. So selected Wikipedia because Wikipedia is an open domain system and developed by the community, and it has a semantic link structure, so you are able to navigate in it. So once again, important that the navigation and the knowledge extraction is rather based on the user navigation, not its own intelligence. So that's why Wikipedia, and so anyone can go on the Wikipedia and develop his own site, his own knowledge, put it in the Wikipedia, and this small engine is able to use this site to answer questions. Or let me say, let user to navigate on this Wikipedia. So conversational agents is usually closed domain. That means someone or a kind of community should fill up this domain, and this domain is specially developed for the small engine, answering engine. And the other thing is that it's based on a kind of artificial intelligence, as I mentioned, so the intelligence in the answering machine. So we try to put, I mean, this Kristiina tried to put this engine into a humanoid robot, and we have this now type real humanoid robot, and we also so we try to put this engine into this robot, and the reason is that in this case we can put some gestures to the robot. So when the robot is answering the questions, then is able to somehow put some gestures behind these answers, and these gestures help us to understand how to navigate on Wikipedia. So when the robot is move up his hands, then it says that there are some links that we can ask for further navigation. So anyway, these gesturing is help us to go further, whether there is a new keyword which has linked to another Wikipedia page. So whenever the robot is, or the engine is reading a link on the Wikipedia, then the robot usually move up his hand. So and in all positions, when some emphasizing on the Wikipedia or some links or whatever, the robot is making different gestures. So this helps the user to navigate on the Wikipedia. So what we have now is we have an RTM module for querying the Wikipedia, and we integrated this module to the virtual collaboration arena system. So now what you see on the slide is if you know the VirCA system, that you know that we have an innovation store, just like Android or iPhone application store. So you are able to pick up components developed by various kinds of community, and these components can be integrated and connected, as you see on the slide, that these are these components, and then you are able to connect it. So anyone else, you can use these components, and now you can integrate your answering machine in your systems. So anyone who is working on VirCA now can use these components. So the next slide shows that this system in VirCA, now you don't see the humanoid robot. Now you see only a book in the VirCA environment, and you can ask this book, and this book will answer your question based on the Wikipedia. Now the answer is written for you, because you don't hear it how to give you the answer. So it's just an example for you. Okay, so then the future goal is fully integrate the now robot into the VirCA system, so it gives you the gestures and answers and so on. So this will be an assistant in the VirCA environment. So whenever you are working in VirCA, or a student is studying in VirCA system, then the student has an assistant who is able to give some answers for the student's questions or something. Yeah, much work was done by Christina, but of course much work was done by us as well.
Do you need the robot after that? Because you built your robot, as we can see on the screen. So do you need a real robot?
No, you don't need a real robot. The virtual robot can work alone, or the engine who is giving you the answer can work alone. So you can integrate it into your robot or your virtual agent or whatever. It doesn't need a humanoid three-dimensional body.
Yes, there was in the past in Word or PowerPoint a companion, a system who was helping you, providing some information depending on what you do. On Word or PowerPoint, is it the same idea?
Yeah, it's very similar.
So the answers are related only to the Wikipedia information. So, for example, if I have a question related to Romania, let's say, and the Romania page doesn't exist in Wikipedia, so the system can offer me an answer, or no? It's just the information that already exists.
No answer, only Wikipedia. The reason is that, as I mentioned, that the intelligence is not based on the answering engine. The intelligence is based on those guys who are filling up the Wikipedia. So in this case, you can open your Wikipedia page and you can fill up with your knowledge. And in this case, the robot will know, or you can use the knowledge you put on Wikipedia. Okay, so it's just like a Wikipedia today. You can search in Wikipedia. Only difference is that this Wikipedia is talking to you, and you can navigate by words. That's why it's called WikiTalk. So it's not actually, it's a talking Wikipedia. Any teacher, any student, anyone can easily fill up information on Wikipedia. That's the benefit. In case of general searching engine, it may not as easy to open your own site for the answering machine. So the answering machine will answer what you want to answer for possible questions.
You know, in Wikipedia, when you search some term, sometimes it offers you, Wikipedia offers you different possibilities. So the user should choose. what does the system in this situation, because it's difficult, you know, I search about a country and I don't know, it's a European country, non-European country, I give an example. So the user should choose, or the system offers you the first choice, is like to be lucky in Google if you want. So the system developed will offer this lucky solution, or?
No, once again, the intelligence is on the user. So the user should select, the system just very blind, just reading the text and the possibilities put on the Wikipedia. So that guy who was creating the Wikipedia page, that guy should be intelligent enough to put the links and the possibilities on the right way. So the answering machine does not change these things, has no intelligence at all. Just you are able to navigate according to the developed Wikipedia page.
Did you try to compare the virtual robot and the real robot in order to see if the user works differently when he has a virtual artifact or a real artifact to help him? So what is the impact of the artifact itself if you have just a virtual one on the screen or a real one which has various movements?
Mm-hmm. So actually the virtual one is better, but it is only for today, because the movements and the outlook and the body is much more nice in a virtual world. But I guess later on, when the real robot will be much better, then that will be better. But this now, today, the real now moves slowly and not so nicely, and so many constraints on the movements. So the virtual life is much more sophisticated. But I guess maybe 10 years later, Japanese robots will be so nice that you may select the real one instead of the virtual one. But yeah. So this now is not as sophisticated as intelligent discussions may need.
If I ask the same question, but for two different manners, it means I'm asking the same thing, but two people may ask the same question by two different ways. So in this case, the system is supposed to give only one answer or two answers, and if so, which one is the correct one?
So the job is on the user, on the head of the user. So if so the user should navigate according to the links provided by the Wikipedia. So if the guy who was creating the Wikipedia did it in a wrong way and gave two wrong links, which is not a unique understanding, then you may not use it very well. So you cannot extract the answer. So again, the intelligence on those guys who are creating the talking sites of Wikipedia. So they have to be clever enough not to give misunderstanding or double meaning or double links on the same questions. Okay, so I guess once again we have a presentation. That was Csaba Antonia from the Transylvania University of Brașov. You see the period of time spent here at Stzaki. The title was Visualization of Grasping and Manipulation of Virtual Objects. The motivation behind this project is very simple. So when you enter a virtual environment, you can see everything, you can hear everything, but you may not feel anything by your hands, by your body. So you feel like a ghost. You can just cross the objects, no any feedback on that. And this is especially a problem when you want to grasp something. I mean, as a teleoperation. So you are standing in a virtual environment in Hungary, and there is a robot, for example, in Japan, and you are controlling this robot through the virtual environment. But whenever the robot is touching something, you want to feel, for example, the force feedback, how strongly the robot is grasping the object. So in the virtual environment, you see the virtual objects, you grasp it, and you want to feel the real force feedback of the real object. But in the virtual environment, you cannot feel it, except you have a special haptic device. But this device, not the real one, I mean, really hard to provide such feeling which exists on the real world. So that was the motivation how we are able to put or forward information and help your brain to understand the force feedback in various ways. So the goal is that grasping a virtual object with or without haptic device, is it possible to do something, maybe provide the force feedback through the visual information or some audio information, because the brain is plastic enough to understand different information in different ways. For example, blind people are able to read text using their finger, so the brain is plastic enough to change that kind of feeling. Or the most simple example, when you are parking your car, you have to go backward. Some years ago we were turning back and looking the distance between us and the car behind us. So we were looking the distance, but today our cars usually have a radar system, and you can hear beep, 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 beep according to the distance between your car and the car behind you. So now today we are rather listening the distance, and many years ago we were watching this distance. That's a very simple example to explain that in some cases sometimes better to hear something instead of looking something. So the question was whether we are able to provide force feedback based on, for example, visual information or audio information. So the goal was to do analysis of the virtual grasping, requires the understanding of arm and hand and finger shapes during the grasping process. So when you can see your hand virtually, how it's touching the object, and try to use a kind of feedback. We used a system which is called measure and shape wrap technology. Is a suit you can put on your body, and you can really follow your movements. This is the chart flow of the system. The key idea was he was also recording some movements through this motion capture suit, and do a database how to grasp various kind of objects. So when he was grasping something, then the robot was able to understand how to grasp, or what's the goal to, for example, pick up a pen, and then the system was selecting the best movements for the robot from this movements database to pick up the span. So it's like a kind of grasping skill database or something like that. So that he was also doing this, and he was merging that kind of grasping skill database with visual feedback information. He was working quite alone, so and was not easy to follow all steps of his research. It was quite deep, but we provide all help we could provide for him. So this is the system. And he is the professor. He is grasping an object using, maybe you see this gloves on his hand here, and this gloves was able to detect all kind of movement. This is the measure and shape wrap that we have. This is a motion capture suit. So anyway, he was checking how he can pick up objects, and he was recording this object, and he used the VirCA system. But what you see on the monitor in front of him, the first as a kind of software of this motion capture suit. So he tried all these things many times, and he recorded these things, and he tried to do the database, and hopefully on the coming CogInfoCom conference he's going to present the results. Okay, so he recorded a plenty of grasping process for offline analysis. He used the basics, he used the VirCA framework, and he learned how to use it. and now we have a kind of long-term cooperation agreement between the Laboratory of Virtual Informatics from Transylvania, University of Brasov, and Stzaki. Based on this long-term cooperation, now we are going to connect Stzaki and the Brasov University and the other university from Hungary, the Széchenyi University, through the VirCA system, and we are building up an online virtual laboratory connecting different devices from different universities, hoping that this virtual laboratory will be an extremely sophisticated and extremely rich, because all of these real and virtual equipments are from different laboratories. So actually we merge the best equipment of the laboratories through this virtual world, and we hope that that virtual laboratory will be extremely rich and sophisticated and open for anyone within Visionair or outside of Visionair as well. So that's the outcome of this TNA. Okay, that's the future goal for the professor. Antonia is to continue on analyzing these grasping movements and of course improving this virtual grasping property.
At the beginning, you have a discussion about a fight between hearing respect to get 3D feedback, physical feedback, in order to perceive the physical feedback, and sometimes said it is better to hear rather than to get physical feedback. Did you measure something like that in this transnational access, or was it just an introduction of a topic? Because I will be very interested by this kind of analysis.
Okay, if you are interested, and I rather suggest you the work of my PhD student. He is going to defend his PhD very soon. He was really taking much effort to give audio feedback when he is touching an object. So temperature, roughness, smoothness, softness, multidimensional feeling was provided through an audio system. So I think his work is much more, much deeply elaborated and measured and tested on a lot of people. If you are really interested, I suggest you to read that work instead of this very short TNA project.